Section C is all about determining angles. And I want you to think back to nice, easy equations that you used to know and love. So how would I get x by itself in this first equation? Since x, we are adding 3 to x, I would choose to subtract 3 because subtracting 3 is the inverse of adding 3. What would I choose to do to get x by itself since it's being multiplied by 3? I would choose division. What's the inverse of square? Is the square root. So the key to all of this add and subtract, multiply, divide, square, square root. All of these are inverse functions. They undo each other. So if we want to choose the inverse of sine, I would ask you to get your calculator out. What is on top of the sine key? If you look on top, this is the inverse of sine. In fact, look on top of the square. What do you see? The square root. A lot of times on your graphing calculator, your inverses are on top of each other. All right, so we're going to set up some equations here. In this particular angle, across from this angle is my opposite, and the 3 is across from the right angle. So what's the hypotenuse? In SOHCAHTOA, what uses O and H is sine. Sine of my angle theta equals 2 over 3. If I want to get theta by itself, we need to cancel out sine using its inverse. So we take sine inverse of both sides. Where you place sine inverse is very important. It can't go after, it has to go in front of each side. Sine inverse cancels out sine. So theta equals sine inverse of 2/3. So if you plug sine inverse, second sign on your calculator, of 2/3 and round it to 3 sig figs, make sure your calculator is in degrees, 41.8 degrees. So you want to first label the sides that you are given in your triangle. Here is my angle. This is my opposite. This is my hypotenuse, but I don't know my hypotenuse, and this is my adjacent. Which one is OA? TOA. Tangent of my angle equals opposite over adjacent. To get theta by itself, take tan inverse of both sides. Theta equals tan inverse of 10/7. Rounding to 3 sig figs. This is important. You need 3 digits for 3 sig figs. So please make sure you have your 0.0 and make sure you have your degree symbol. And this is section C. All right. Section D is using geometric figures and remembering some of the pieces. So in an isosceles triangle, two sides are congruent, and then the base, that when you draw in your hypotenuse, that splits your base in half, and your angles, your base angles are also congruent. Square and a rhombus, the diagonals bisect each other at right angles. Both of those will be important to remember. In a kite, the diagonals intersect at right angles, then these two sides are congruent, these two sides are congruent. So remembering your geometry stuff. In a tangent is just when the line butts up to the circle at one point. Semicircle, if you connect a semicircle in any point in a semicircle, if you can connect to the diameter, this will always be a right angle. Finally, in a circle, this would be a chord. So your radii in a circle are always congruent. Therefore, this would always be an isosceles triangle. So your basic angles are congruent, and it splits the chord in half when you draw a right angle. Okay. So this marking shows us that we have an isosceles triangle. So my base angles are congruent. When I draw my height in at a right angle, that cuts my base length in half. So let me just draw this out. If this is 5, this is 67. If this side is x, this side is x. This is my right angle. So in here, this angle, x is the hypotenuse, 5 is the adjacent. So TOA, AH, is connected by cosine. Cosine of 67 equals the adjacent over the hypotenuse. I need to get my x out of the denominator. Every time you have this situation, you're going to multiply by x and divide by cosine 67. These two really just trade places. Then in your calculator, take 5 divided by cosine 67, 3 sig figs, 12.8, and everything is measured in centimeters for this triangle. So be very careful. If you know the angle, you just do cosine of the angle. If you're looking for the angle, you use cosine inverse. All right, here we have our right or our congruent sides, which means this is my isosceles triangle. So this cuts it in half, 2.6. And let me just call this, say, x. Oops. Oh, yeah. Because if this angle here, this is my opposite. Here's my right angle. This is my hypotenuse. Sine of x equals the opposite over the hypotenuse. So to solve for x, see here I knew the angle, so I take cosine of the angle. When I'm looking for the angle, I do sine inverse to get the angle by itself. So when you plug that into your calculator, you're going to get approximately 18.255. Now, the original picture wants this whole angle. The entire angle alpha is double the angle because I cut the angle in half when I drew in the right side there. So I'm going to take my exact value and take this times 2 and round to 3 sig figs and get 36.5 degrees. Okay, so here you need to draw a picture of a rhombus. A rhombus is like a tilted square, but at least they should be straight, right? A tilted square has 4 congruent sides, but the angles are not congruent. The diagonals bisect each other at a right angle. So if my diagonals are 10, that means each one's 5 and 5, and my other ones are 6, so 3 and 3. It said find the smaller angle of the rhombus. So let's look back. So notice this is much more tilted than mine. These two angles are smaller than these two angles. So here's what I did. So if I want to figure out an angle, my angle is going to be opposite over adjacent because the hypotenuse is what I don't know for all of them. I said, let me do tan inverse because I'm looking for an angle, so I use my inverse. I did both 5 over 3 and 3 over 5. I'm going to do both of them, and I'm going to see which one is bigger or smaller because I want the smaller side. So this gave me 59 degrees, and this one gave me 30.6 degrees. So this is the one I want, but I need to find, keep in mind when I drew the diagonals in, it cut them in half. So I need to take 2 times this angle, and it ends up being 61.9 degrees. So what I did is set up both situations of 5 over 3 and 3 over 5 using the opposite and my adjacent. Realized that this was the bigger angle, so this was the one I needed, and doubled it. Okay. In a trapezoid, the height all the way across my trapezoid is the same. And when I draw my height in, that creates a right angle. So let's focus on this one first. If this is 65 degrees and this is 10, I need to find my height first. So if this is my angle, my height is the opposite. The 10 is the hypotenuse, OH. That is sine of 65 equals H over 10. So to get H by itself, multiply both sides by 10. So my height is approximately 9.063-ish. So that's going to be the same value of my other height. I just left this into my calculator so I could find my exact value later. Now, I'm also going to find this triangle with 48 degrees, and this is X. This is my height. Same height as over here. These are the same. So if this is my angle, this is my right angle, this is my opposite and hypotenuse. So once again, we're going to use sine of the angle 48 equals the opposite divided by the hypotenuse. So then to get x by itself, multiply both sides by x. X is going to be our value from our height divided by sine of 48. So I just kept this answer here in my calculator from when I calculated over here, then take it divided by sine of 48, 3 sig figs, and always put a label with your answer. All right, last but not least, I'm going to have my Promethean board draw us this. And here we go. And let's draw. Not too terrible. All right, if this is my center, my radius should be congruent. It says the radius is 6.5 and the chord subtends an angle of 112. All right, so when I draw my height in, that splits my angle in half. So half of 112 is 56. This side is 6.5, my hypotenuse. I want to find the opposite length of x. That's this right here. So OH is sine of 56 equals opposite over hypotenuse multiply by 6.5 to get x by itself. X is approximately 5.3887. And if I double my side, because this was just this part, I should have two of them. The chord equals 2 of my x's and 3 sig figs. So notice I kept this as x. I doubled it, but I labeled that as also my chord.